Hello and all, welcome to the Math Magic Show. In this one, let's take a look at finding the integral there of x multiplying on the root symbol 1 minus x. So let's go through the process. First, what I want to do is use variable substitution. So I'm going to let u equal 1 minus x. After that, I'm going to differentiate. So when I do that, I have that du equals negative dx. That is so because the 1 goes away, it's a constant, and the derivative of a constant is 0. And then negative 1 stays in front of dx, so you get negative dx. After that, you just divide through both sides by negative 1, so it's going to tell you that dx is equal to negative du. I do discuss the kind of conceptual underpinning of variable substitution in another video in quite some considerable detail, using only pictures. Okay, this is a purely mathematical approach here, so let's take a look. That will allow us to replace dx with negative du. It will also allow us to replace under the root symbol the quantity 1 minus x with u. We also have to, however, figure out how to replace x with something in terms of u because we want to work in only one variable. To do that, we're going to take u equals 1 minus x and just solve it for x so that we can stick it in for x in the integral. So I'm going to have u minus 1 equals negative x, and then after that, of course, you simply divide through by negative 1, so it's going to tell you that negative u plus 1 equals x. And lastly, just perhaps write it a bit more naturally so it looks like x equals 1 minus u. So these are all the pieces that we need, and now we can replace dx, we can replace 1 minus x, and we can replace x. So let's go through that process. I've done that right here. So as you can see, I'm replacing x with 1 minus u. That's from this step. I'm replacing 1 minus x under the root symbol with u, and I'm replacing dx with negative du. Now at this point, when you look through this, you see there's this negative in front of the du. It's a negative 1 basically, so you can just place it outside the integral. So when you do that, it's going to look like this. So the negative is outside now. Now the next point, you always try to apply the simplest possible rule you can find, nothing too fancy. So in this case, I will use the power rule. But before I do that, I need to take the square root of u and just distribute it to each term. So when I do that, it's going to look like the following. I'm going to have the u, and I'm rewriting this portion right here, the square root of u, as u to the 1/2, because that clearly identifies the exponent. And I'm going to distribute it to the u to the first, and I'm also going to distribute it to the 1. So when I do that, it's going to give me the following now. On the bottom, I have u to the 1/2 minus u to the 1/2 plus 1. So now we just continue. At this point, as you can see, you basically have a variable and you have some exponents, so the power rule will be applicable ultimately. Let's continue with the next step. So what I'm doing is the following. In this position, I'm replacing the 1 with 2 over 2, so it's going to give me 1/2 plus 2 over 2. I'm doing that again as a reminder because you want to make sure the bottoms are the same whenever you add any fractions, anywhere they're located essentially. Okay, at the next point, when I simplify that, it's going to give me e to the 1/2 minus u to the 3/2. You see that you have u to the 1/2 and you have u to the 3/2, so the 1/2 and the 3/2 are the quantities now to be used when you apply the power rule. So let's take a look. Let's do that the next step here. It's going to look like this. And I need to talk about this because there's a lot happening here, as you can see. So the first part is up here. It says u to the 1/2 plus 1. So I'm taking the 1/2 from above and I'm adding 1 to it. That's what the power rule states. I'm taking the 3/2 up there and I'm adding 1 to it. And the bottom, according to the power rule, you have to take whatever this exponent is up here, so 1/2, and you have to add 1 to it also. Remember, it's u to the m plus 1 over m plus 1. And the bottom, and this one, I also have now 3/2 plus 1. So that's application of the power rule. Notice that the negative is kept outside the giant parentheses. So now let's take a look at the next step. So the next step, I'm simplifying the fractions basically that I encounter. So I have u to the 3/2 from 1/2 plus 1, and the bottom 3/2 also because it's 1/2 plus 1. I have 3/2 plus 1, that's 5/2, and then the bottom 3/2 plus 1 is also 5/2. So just simplifying all the fractions, adding them up. At the next step up here, let's take a look at that. So here I have the flipping of the fractions. So remember that at the last step down below here, I had 3/2 and 5/2 on the bottom. So now when I go on to the next step, I just have to flip them up top. So when I do that here, I have 2/3 and I have negative 5/2. At the next step, as you can imagine, the goal would be to, for example, replace u with what it represents in terms of x. So remember, don't forget that basic fact that that's equal to, from up here, u equals 1 minus x. So I'm going to make use of this fact, u equals 1 minus x, and just plug it in for u. So now what I'm doing is I'm replacing u with 1 minus x. And lastly, I observe that on the outside I clearly have a negative 1. So I can distribute out to each term inside the parentheses. So it's going to go over to the 2/3 and it's going to go over to the negative 5/2. So finally, when I do that, it's going to give me the following answer. I have negative 2/3 as a coefficient. Then I have 1 minus x to the 3/2. Then I have a positive 5/2, and then I have 1 minus x to the positive 5/2 and plus c at the end. And then this is the answer. And that is it for me. Thank you so much for watching. Please give a like and subscribe. I hope it's been somewhat helpful. All the steps are here. Usually to get good at math or anything, you just have to learn to respect the tiniest detail. Because one small mistake in one of these problems and you will lose 15 minutes of your life with nothing to show for it. That is how mathematics operates. It is very unloving and unforgiving. I'm kidding, but it's also based, I think, on some fundamentally deep truths that seem to spring from somewhere in our minds. I don't know, I think it's fascinating. Thank you. Please have a like and subscribe, and I'll see you in another video.